Good afternoon. My name is Matej Andrejasic. I come from company Pipistrel. We are located in Slovenia. First, I would like to tell you something about our company, then how are we involved in I4MS, some results, and what are our benefits. We are, like I said, situated in Slovenia. There are approximately 85 employees. A little bit more than 20 in R&D area. We're a producer of ultralight and light aircraft. For example, at the top left corner you can see our ultralight aircraft. It is Virus Shortwing. It is actually a winner of NASA efficiency competition 2 times, in 2007 and 2008. We produced more than 600 airplanes of this family, actually. Lately, in the last few years, we entered into general aviation industry with our new 4-seater Pantera. It is at the bottom right photo. Then at the bottom left corner, you can see a weird-looking airplane with 2 fuselages. We're actually quite proud about this. This is it's NASA Green Flight Challenge winner in 2011. So we put together 2 fuselages, make it electric. It's purely electric, and produced the first 4-seat electric aircraft in the world, actually, and won the competition, sponsored by Google, actually, in the USA. And its little brother at the top right corner is Taurus Electra, also purely electrically driven, and it is already in serial production for a few years now. So as you can see, we are quite strong in aerodynamic efficiency and electric propulsion systems. Now I'd like to show you we're involved in I4MS through project Fortissimo. We have an experiment which is cloud-based simulation of aerodynamics of light aircraft. We're as an end user, and the actor, for example, is a HPC provider. We use OpenFOAM software. And why did we enter this project? What is the motivation? We really wanted to improve the fidelity of aerodynamic simulations, because that gives us a better prediction of the forces that act on the airplanes, so we can design the aircraft better with better efficiency. For that, we used new turbulent model. I will show you in the next slide just a few results. And we really wanted to improve our knowledge about running and handling and, of course, post-processing, very big cases, because we were not used to that. So some of the results. On the top left corner, you can see a slice through a mesh that's a leading edge of the wing. And you can see that the mesh is quite coarse. For example, the thinnest boundary layer has around 1 millimeter. But in order for us to use new turbulence model, we had to use much finer mesh. And on the top right corner, you can see mesh where the thinnest layer is 2 to the -5 meters. So we scaled down 40 times the mesh, which means we went from 5 million to 10 million cells, which was typical for us on our in-house cluster. We went to 100 million cells in mesh. So that's 10 to 20-fold more. It was quite good for us. And at the bottom, you can see one of the results. This is, like I said, our new aircraft Pantera. So the aim of this project was to simulate the airflow around a complete aircraft with this low Reynolds number turbulence model, which means very fine mesh. There is surface distribution of turbulent kinetic energy dissipation, which means, simply put, first two-thirds of the wing have laminar flow, and the last third, like you see, it's more whitish, has a turbulent flow. With this turbulent model, we can predict where the flow transits from laminar to turbulent flow, and with this data, we can predict the drag forces more accurately, and that's very important for us, of course. So the benefits of us joining I4MS or Fortissimo. Of course, we learned how to use an HPC, which means that next time we will need it, we will know exactly how to start, how the whole HPC workflow goes. We will directly go to simulations. We will know how to start them. We will know approximately how long it will take us, and so we can know the cost of this simulation, so which is very important in the design phase of for example, new aircraft. And of course, HPC allows us to evaluate new methods and new models, like I said, new turbulence model for us. And of course, this gives us a better design and of course also faster design cycles. So that's about it. Thank you for attention.